Hello guys, welcome to Tech Invent. My name is Girish and today we will be discussing about quantum computers. We will try to find out what makes them so superior to conventional computers. Well, recently on May 3rd, 2017, China developed the world's first quantum computer. Its developer claimed that it is 24,000 times faster than its counterparts in the international market. Also, it is not a general purpose computer, rather, it is a task specific computer, which means it can only perform limited tasks and not day to day tasks. Even now, a lot of work has to be done to develop a fully functioning quantum computer. Before discussing more about quantum computers, let us first talk about the conventional computers. The first conventional computer developed was as big as the size of a room. But as the technology advanced, the size of the computer decreased while its computing power increased. This was mainly because the vacuum tube used earlier to store data was replaced by transistors. Everything is represented using strings of zeros and ones. Well, what actually are these bits? These bits are nothing but representation of states of a transistor. A transistor can be in two states, either on or off. Binary bit 1 represents on state, whereas binary bit 0 represents the off state. So it is basically not wrong to say that a conventional computer depends on transistors. But the problem with transistors and thus with conventional computers is that we can't extract any more benefit from a transistor computer. It has halted the Moore's law. According to Gordon Moore, the co-founder of Intel, the power of computers should double in approximately every 2 years. But we know this is not the case. We have already developed the smallest and the most powerful computer possible that can be developed using transistors. However, there are still many problems that needs to be faced, and to solve these problems we need to build computers using a different approach, and one such approach is quantum computing. Quantum theory basically studies the behavior of atomic and subatomic particles. In quantum theory, everyday laws of physics does not apply. One such example is the duality of light. We know light is both a particle and a wave at the same time. Now just imagine a transistor being in both on and off state at the same time. Well, that's the type of crazy things that can happen in the quantum world. Now, let us try and understand the basics of a quantum computer. We know data is represented using bits in conventional computer, but in quantum computers, data is represented or stored in the form of quantum bits or simply qubits. Now, what are these qubits? In conventional computers, bits represented the state of a transistor. So what does a qubit represent? Well, qubit stands for quantum bits, so it is quite clear that it has something to do with atomic or the subatomic particles in the atom. As bits represent state of a transistor, a qubit represents different states of an atom or any of its subatomic particle. We already know the kind of bizarre things that are possible in the quantum world. An electron inside an atom can be at two different places at the same time. Quantum computing exploits this fact of quantum theory so that a qubit can be in more than one state at a given time. Thus, a qubit can be either 1 or 0 or both 1 and 0, and it can also take any value between 1 and 0. This means that more amount of data can be stored in just one qubit, and this data can be processed quickly as the computer has to process just one qubit. We can manually change the state of a qubit by application of laser beams, electromagnetic waves or radio waves. So to change the state of a qubit, we need less energy as compared to bits in the conventional computer. These are one of the many reasons that makes a quantum computers superior to conventional computers. Thank you guys. If you liked my video, then please subscribe my channel and follow us on the blog link given below. And if you have any queries, please feel free to ask me in the comment section.